Welcome to a screencast on the ratios of sides in right triangles. Previously, we thought of the sine and cosine functions in relation to a point traversing a unit circle, where the sine of t is the height of a point that has traversed t units along the circle from the point 1, 0, and cosine of t is the horizontal location of a point that has traversed t units along the circle from 1, 0. In this video, we will change perspective and learn how the sine of t and cosine of t can be thought of as a ratio of the sides in a right triangle. Consider a right triangle with a hypotenuse of length 1 lying in standard position in the unit circle, with one vertex at the origin and one leg along the positive x-axis. If we let the angle formed by the hypotenuse and the horizontal leg have measure theta, then the coordinates of this point on the unit circle are cosine of theta, sine of theta. As a result, the right triangle with hypotenuse 1 has horizontal leg of length cosine of theta and vertical leg of length sine of theta. Now let's consider a similar right triangle with hypotenuse of length r, where r does not equal 1. Then we can view this triangle as a magnification of a triangle with a hypotenuse of 1. These observations allow us to conclude that the horizontal legs of the right triangle with hypotenuse r has measure r times the cosine of theta, and vertical leg with measure r times the sine of theta. Because the two triangles are similar, the ratios of corresponding sides must be equal. So if we consider the two hypotenuses and the two horizontal legs, we have r divided by 1 equals r times the cosine of theta divided by the cosine of theta. We can rearrange this equation by multiplying both sides by the cosine of theta and 1 over r. And this gives us the cosine of theta over 1 equals r times the cosine of theta divided by r. From a geometric perspective, this equation tells us that the ratio of the horizontal leg of a right triangle to the hypotenuse of the triangle is always the same regardless of r, and that the value of that ratio is the cosine of theta, where theta is the angle adjacent to the horizontal leg. Similarly, the equation involving the hypotenuses and the vertical legs of the similar triangles is r divided by 1 equals r times the sine of theta divided by the sine of theta. And this can also be rearranged to get the sine of theta divided by 1 equals r times the sine of theta divided by r. This equation shows that the ratio of the vertical leg of a right triangle to the hypotenuse of the triangle is always the same regardless of r, and that the value of that ratio is the sine of theta, where theta is the angle opposite the vertical leg. We can summarize these recent observations as follows. In a right triangle where one of the non-right angles is theta, and ADJ denotes the length of the leg adjacent to theta, OPP the length of the side opposite theta, and HYP the length of the hypotenuse, the cosine of theta equals adjacent divided by hypotenuse, and the sine of theta equals opposite divided by hypotenuse. In subsequent videos, we will practice using these new perspectives of the cosine and sine functions to determine missing information in right triangles.